Hi guys, I'm back in. This is Growth and Decay Part 2. I'm sorry, my last video cut off because I ran out of time on it. So we were going through this problem, and it's growth and decay factor problems. So, and if you aren't here yet and you don't know what growth and decay factor is, please go back to the first part of this video. I'll make sure to label them Part 1 and Part 2, but just make sure you watch Part 1 before you watch Part 2. Okay, so we've already gone through, I own a bank, lease deposits $100. The interest accumulating is 25% a year. What is in her account at the end of the first year? Okay, so that's pretty big, so let's break that down. So I always like to underline what's important. So Lisa deposits $100. So I know that my equation is y equals a times b to the x. So I know I'm looking for a starting value. Well, she starts out with $100, so that's her starting value, is 100. Okay, the interest accumulating is 25% a year. That was pretty big. Let's go through that. Okay, so the interest accumulating means that she's gaining money off that $100 being in my bank. So it's like me paying her for putting her money in my bank. So accumulating was one of my growth words. So that means she's gaining money. And she's gaining 25% a year. So 25% of that 100 is going to be, we're going to change it to 0.25 because we have to work in decimals. So what is in her account at the end of the first year? Well, we don't know that yet, but we know that our first year is our exponent, because remember that x is always time, and because time is always independent, and x is always independent. So, and since we know that it's growth, because of this word right here, because of accumulating, because that was one of our growth words, and also whenever it says interest, by the way, that is also one of the growth words, because it's like interest, or gaining money. So we know that we can fill in this equation, but I just zapped it to that. How'd you get that? Well, we've gone through it a little bit. So 100 is your starting value, is your A. Your 1 is your growth factor. 0.25 is your growth factor, and the 1 is because it's the growth and not the decay. And then the 1 right here is because we're looking for at the end of the first year. So we're looking for just after 1 year. Well, anything to the first power is just itself. That's pretty simple. So we know that 100 times 1.25, we're going to move it over 2 decimals because we've got 2 zeros here. And then you're going to get y is equal to 125. And so since we know that y is the money that we're looking for, and we know that y is dependent on x, we can say that y, so how much money is in the account, is going to be $125. So we know that this was growth because she started out with 100 and went to 125. And we know that that's growth, also because of interest and accumulation, or accumulating. So on to the next problem. Brandon's car value depreciates by 25% each year. He bought the car for $1,000. How much is the car worth after 1 year? Okay, so I've gone through and underlined what is important. So we have the same y equals a times b to the x, but this time it's different. Now we have depreciates right in here. So depreciates is a lot different from accumulation. Depreciates is literally the opposite. Depreciates means decay, means decreasing. And so it's decreasing by 25% each year. So we know that it's 75% of what it was when he bought it is left each year. So he bought the car for $1,000. So 75% of $1,000 is left after 1 year, which is nice because we only have to find it after 1 year. So we have our equation. So y equals a times b to the x. So our a is our starting value, which is $1,000, because that's how much he bought it for. Our b is our 25%, which is our multiplier, which is either our growth or decay. And since we know it's depreciating or going down, we know that's decay. So we're going to take, and if you remember from decay, we're going to take 1 and we're going to subtract our factor from 1. So since it's 25%, you're going to go 1 minus 0.25, and then you're going to get 0.75, because that's how much you have left. And we're looking for after 1 year. So remember, our x is time, so that's 1 year. So if we were to multiply this out, you would get 3 zeros, so you go 1, 2, 3, which is 750. So we know that our y equals 750,